Hello, Mr. Fry's Geometry. This is 4-9. This was something that was done in class. I'm not sure if you onliners have to do this or not, but this is the compound probability task cards review. And I'm going to go through at least half of them here and show you the cards also as I go through these. So taking a look at number one, let me scroll back up here. Number one, we have a coin is tossed and a number 1 through 8 is chosen at random. What is the probability of getting tails? And a number greater than 2. So number greater than 2, there's 6 of them out of the 8 numbers that are there. Getting a tails is 1 out of 2 chances. So you multiply those together and you get 6/16 or 3/8. You just do 3 divided by 8, or you could just do 6 divided by 16, and that's a 37.5% chance of that happening. In the boxes I saw in class, they were writing independent or dependent in there, so this would be an independent. Dependent is like if it depends on if the first thing happens, if you actually get it or not, and we'll talk about those later on when like you pull a card out of a deck of cards and you don't put it back, and then the next one you're gonna pull another, it's not replacing whatever. That's what those dependent ones are. So taking a look at number 2, we're looking at a day of the week is chosen and a month is chosen at random. What is the probability of choosing Saturday and a month that begins with the letter J? So Saturday is 1 out of 7. A letter J month is 3 out of 12. That would be 3 out of 84 or 1/28. 1 divided by 28, or you could just do 3 divided by 84. You're going to get 3.6%. Okay, and that's independent also. So if you're having problems with simplifying, you could go to this calculator soup, calculators, math, fractions, simplify. Just Google it, fractions simplifying. Let me see how I Googled it. Let me see it real quick. It just keeps taking me back. I think I just typed in fraction reducer calculator is what I Googled, and it's the first thing that popped up. So that will help. Okay. Let's skip down. You try 3 and 4 on your own. Don't worry about making mistakes. Just work them out. Correct your mistakes, and that's the learning process. So number 5, let's take a look at number 5. A 6-sided die is rolled, then a quadrilateral is chosen at random from a parallelogram, rhombus, rectangle, square, and trapezoid. What is the probability of getting a 5? And then a quadrilateral with 4 congruent sides. So getting a 5 on a 6-sided die is 1 out of 6. There are 2 equal sides, that quadrilaterals that have equal sides. That would be rhombus and square out of the 5, so 2 out of 5. So you just multiply those, you get 2 over 30 or 1/15. You divide either one of these, you're going to get 6.7%. I'm rounding the percentages. I'm rounding those percentages so that you have it rounded to the nearest tenth, and this is independent. Okay, the next one. I have number 6. Olivia guessed on the last 3 multiple choice questions on her science quiz. If each question had 4 answer choices, what is the probability that she got all 3 questions correct? Well, let's take a look. She'd have 1 out of 4, 1 out of 4, 1 out of 4. You multiply them together, and that's going to be 1 out of 64, and that is going to be independent also. So, and it would be 1.6% chance of guessing all those. Okay, so let's take a look at number 9. Number 9, you try 7 and 8 on your own. Josh and Alex play on a basketball team. Josh made 9 out of 16 shots, and Alex made 15 out of 20 shots based on their performance, based on these numbers here. What is the probability that both boys will make their next basket? So both of them making their next basket. Okay, so what I did is I took, he's 9 out of 16, and he's 15 out of 20. So both of them making the next one. What's the probability of that happening? Multiply those together, 135 over 320. I just took 135 divided by 320 and I got 42%, and that's independent. If you had to reduce that, if I click on that, enter, this is how that works. Let me go 135 over 320, and I hit calculate, and it gives you the 27 over 64. So that would be 27 over 64. And if you just divide either one of these, you're going to get the same percentage. Okay, for number 10, let's take a look at number 10. Chance of rain Monday is 20%. And Tuesday is 70%. What is the probability that it will rain on Monday, but not on Tuesday? Okay, so Monday's percentage is 20 out of 100, or 20%, and it's 1/5. Tuesday is 70, but not rain then would be, if it's 7 out of 10, that means it would be 3 out of 10 not to rain. So we multiply those together, the 1/5 and the not to rain on Tuesday, and you get 3 over 50. 3 divided by 50, you get 60%. That's independent also. And finally, we're going to get to some dependent ones. Number 13. The numbers 1 through 25 are written on slips of paper and then placed in a bag. A number is chosen, it is replaced, then another is chosen. What is the probability of getting a perfect square and then an odd number? Perfect squares, well, there are 5 perfect squares. I have the list of perfect squares here from another class. So there are 1, 2, 3, 4, 5 of them, 5 out of 25. And then, what was the other one? And getting odd number. There's 13 odd numbers in 1 through 25. So you multiply those together, it's 65 over 625, or 13 over 125, which is 10.4%, and it is independent. Now we get to our first dependent. The numbers 1 through 25 are written on slips of paper and placed in a bag. A number is chosen is not replaced. Then another number is chosen. So it depends on that not replacing it. So what is the probability of getting 2 numbers greater than 10? So we're going to have 15 over 25, and then 14, because you're going to pick one, and you're going to have one less for each. So 14 over 24. That would be 210 over 600, or 7 over 20, which is 35%, and that's dependent. Okay, 17. 17, a piggy bank contains 20 pennies, 18 nickels, 25 dimes, and 12 quarters. A coin is chosen, it is not replaced, and another is chosen. What is the probability of choosing 2 dimes in a row? Dimes, see, we have 25 of them, and it's going to be 25 out of all the coins is 75 added up. You don't replace it, so now you're going to have 24 dimes possible out of 74 coins. So that's going to be 600 over 5,550, or 4 over 37. If you divide either one of these, you get 10.8%, and that is going to be dependent also. Number 18. Mrs. Lane had 16 girls and 12 boys in her homeroom. She must randomly choose 2 students to serve as representatives in the student council. What is the probability that she chooses 2 boys? Well, girls and boys equal 28 students. So she'll pick 1 boy, and then she'll pick another out of 11 out of 27, because that's dependent on her picking the first one. So that's going to be 132 over 756, and I didn't simplify this one. I'll do it for you in a second, but if you divide the top by the bottom, the numerator by the denominator, you get 17.5%. Let me go back on here and show you 132 and divide it by 756, and I calculate it. I get 11 over 63. So if I needed to, I don't really think I needed to, but 11 over 63, and that equals that 17.5%. All right, good luck on the other ones. Make mistakes, learn from them, and No worries. Good luck.